This problem is about Lewis structures and formal charge. Please read the problem, plan how to solve the problem, implement the solution, and then compare your answers. So let's begin by writing the structure Cl and O. We place nitrogen in the middle because it's the least electronegative compound. Now we count the valence electrons. Chlorine has 7, nitrogen has 5, oxygen has 6. In total, we have 18 electrons. For bonding, we are using 4 electrons. We have 2 bonds. The rest of electrons to distribute will be 14 electrons. So the first approach then would be to assign 6 electrons to chlorine, 6 electrons to oxygen, which is 12, and we have 2 electrons left for nitrogen. We can think about this structure as a way to complete the octet rule, and we see that the octet rule is met for chlorine, is met for oxygen, but it's not met for nitrogen. So what we need to do is to move a pair of electrons to form a double bond. So the first structure will consist of moving the pair of electrons from chlorine to form a double bond with nitrogen. We have 2 electrons for nitrogen, we have 4 electrons left on the chlorine atom, and we still have 6 electrons on the oxygen. Octet rule is met for chlorine. We have 2, 4, and 4 is 8. For nitrogen, we have 2, 4, 6, and 8. And for oxygen, we still have 8 electrons. So we call this structure 1. Similarly, we can meet the octet rule by moving electrons from oxygen. So in this case, we will have 2, 4, 6 electrons from chlorine, 2, 4 from oxygen. We are going to move 2 electrons from oxygen to form a double bond with nitrogen. And again, we meet the octet rule for chlorine, for nitrogen, and for oxygen. This we're going to call it structure 2. So now, in order to determine which one is the most important one, what we're going to be doing is determining the formal charge of these 2 structures. For 1, we will look first at the formal charge of chlorine. And for that, we have the number of electrons of chlorine will be 7 valence electrons, and we are going to subtract the lone pair of electrons, which is 4, and the ones that are shared in the double bond, which is 2. That gives a formal charge of +1. The formal charge of nitrogen will be 5 minus the lone pair of electrons, which is 2, and those that are forming bonds, which are 3, gives a formal charge of 0. And lastly, the formal charge of oxygen will correspond to 6 valence electrons minus those electrons that are non-bonding, which are 6, and the one that is being used by the single bond. The formal charge will be -1. For structure 2, we have 7 electrons for chlorine, 6 being shared, 6 for the non-bonding, and 1 that is being shared, which gives a formal charge of 0 for chlorine. For nitrogen, we have 5 valence electrons minus non-bonding, which is 2, plus 3 corresponding to the shared electrons. Gives a formal charge of 0. And lastly, for oxygen, we have 6 valence electrons minus 4 non-bonding electrons and 2 corresponding to the shared electrons in the bond, which gives a formal charge of 0. So if you look at these structures, and we look at the rules to define what are the best structures to choose, we see that for the first structure, chlorine will have a formal charge of +1 and oxygen will have a formal charge of -1. This is not going to be a good combination because it's attributing a positive charge to chlorine, which is more electronegative than any of the elements present. On the other hand, structure number 2, the formal charge is minimal, it's 0 for all of the 3 atoms that we have here. So this is a favorable structure. So therefore, what we have, the Lewis structure that has the lowest formal charge will be structure number 2. And we can determine that in this particular case, the formal charge is 0 for each of the atoms in this particular system.